advances in cloud edge and optimizing the application experience. And so, Kevin, we'll kick this one off with you. Everybody's talking about distributed data centers and the computing, moving computing to the edge. That was at the beginning of this year the hot topic. So what are the big issues architects need to be thinking about as we move to this world where we have cloud edge computing?
Yeah, so I think the big picture is that you're no longer really programming servers. The new unit of computing is the data center, and you actually are running a distributed application across the entire data center. And with the edge, it really fragments even further. So instead of a giant centralized data center that has 10,000 computers, you have 10,000 data centers at the edge, each of them with a smaller rack, but still performing all kinds of new functionality. And the key things that you have to consider there are cloud native, so that you can dynamically do things. You have to be secure, because everything is untrusted. In the edge, you're going to be plugging in cameras and devices that you simply have no control over. There's no security guard the way there is a centralized giant data center. And then making everything software defined and hardware accelerated. And doing all of that together really requires a lot of horsepower, a lot of innovation, AI and machine learning, because all of these edge applications are unsupervised. When we look at the way people use the applications today for IoT, it's mostly the phone. And they're curated by humans that are controlling what's happening. And it's pretty slow. The response time that a human needs to respond is actually pretty slow. When suddenly you're controlling things that need to react in real time that aren't curated by humans, that have latencies of the 10 millisecond sort of time frame, you really need autonomous AI machines. You need networking that is reliable, that delivers, you can't have hiccups in your network that have huge latencies. So it really changes everything. And then the security that I mentioned as well.
Okay, just a quick follow-up. Can you just explain a bit more about what you mean by cloud native networking versus other networking?
Yeah, so in the traditional networking environment, you really had extremely long-lived sort of monolithic applications. The cloud turned that on its head. So if you're going to deliver huge amounts of scalability to millions of users or billions of devices, you no longer can build a giant monolithic platform that runs on one computer. First of all, the problems that you're solving are much too large. You need a distributed mode. And to do that reliably and scalably, you have gone to what's called the container-based solutions. So instead of having a monolithic app, you have these ephemeral containers that are coming and going all of the time, and you need to automate everything. So automation of the networking that connects between all of them, the discovery, overlay networks with things like VXLAN, all of this is dynamic, coming and going, so that you can scale up and build the data center that you need to run your application. And when you're programming, you're not programming the server, you're programming the entire data center, and it's going to dynamically compose exactly the computer that you need in that data center. So maybe you have a huge AI task if you're running something like 5G and the radio, the cloud radio. Maybe you have something that needs a ton of data, so you need more storage connectivity. And doing that dynamically with containers that are coming and going all the time, you simply can't manage that with a very smart IT guy sitting in the corner. Everything needs to be automated and coming and going dynamically.
Okay, great. John, I'll quick turn it over to you for a second or two. Obviously, Cisco is working a lot with cloud providers. What are you seeing in terms of the key areas for them in cloud networking?
Sure, yes. So what happens is, Kevin mentioned how modern enterprise applications are distributed. And what happens then is often distributed one cloud, multiple clouds, on-prem, which could be edge and other places. You have all these different places where you have components, you have these cloud native components, microservices, and so forth operating. And you want to network all of them really well in order to get the latencies and the reliability and so forth that was mentioned. So this includes things, for example, to go from a site to a cloud, or from one cloud to another cloud, because you may use AWS for certain things, Azure for other things, so forth, or as well as site to cloud to cloud to site in order to leverage the backbones that the cloud providers have for across continent, across ocean, sort of really fast connectivity and stuff like that. So networking is especially important in this context. In addition, what people really care about is not the networking, right? We don't care about networking. We actually care about applications. And then the question is, how can you get the the application developers and DevOps want to accomplish with their applications to the cloud native networking and to the networking in general? Historically, this has been a troubling problem because the DevOps people try to describe what they want to do to the NetOps people, and then the NetOps people try to put it in the network and so forth. But that takes a while and isn't as automated. A number of the colleagues here had mentioned the importance of automation. One of the things that we have done recently with Google, with Google Cloud Platform, GCP, is to automate going from the DevOps to NetOps. So what we're doing right now, and this is with proof of concepts, is the application developer and the DevOps can describe what they're trying to accomplish with their application, with the different flows and so forth. What are the network requirements? That gets incorporated in something called Service Directory that Google has. And then our SD-WAN manager, vManage, basically subscribes to and gets that content, gets that metadata for the application, and the NetOps then can use that to set the network policies and security policies. And so what that happens is it automates the connection between DevOps and the network policies and security policies. And if the business decides to make a change, to reprioritize or to move compute from one place to another, or whatever makes most sense for them, it can very quickly be turned into reality. Similarly, if from the network side you realize, hey, for whatever reason, this region of the country is extra congested, or there's denial of service attack or something occurring, that feedback can be provided to the DevOps people, and then they can migrate their cloud apps to a different region. So it really makes a more natural connection between the DevOps who are creating this cloud native applications, as well as the SD-WAN and the cloud-to-cloud networking and so forth. So there are a lot of exciting things happening building these bridges to make these distributed applications work much, much better.
Great, thanks, John. Mansoor or Bob, any comments before we move to the next topic?
Maybe one. Bob, do you want to go ahead?
I mean, the only thing I would quickly add, I think what we're seeing the trend, right, is as all the applications kind of go to the cloud and, worker and employees and people go to their homes and remote, I think people are looking to the on-ramp to the internet, right, that edge cloud as a place to deal with the data plane, right? I mean, we knew that all the content management guys, all the content went to the edge early on in the early days of the internet. So when you look at things like gaming, anything that requires low latency, they want to start moving the compute and storage to the edge. I do think the one issue that we're going to have to deal with is, data centers tend to be built near power centers. The on-ramp to the internet typically is not near the world's largest power, dams and stuff. So I think that's going to be one, as we move more compute and storage to the on-ramp to the internet, where's all the power to power all these new data centers that are moving to those on-ramps?
Yep. Yeah. So maybe the only thing I'll add here is that, yes, we're seeing these data centers get more and more distributed. And so, for all these reasons that were mentioned. And so, one of the challenges, and yes, the applications are really important, but another big challenge is the data itself, right? And when you're measuring a lot and there is, this need to collect all this telemetry and all this state, it's I think an interesting problem is how to manage this data. And Apstra specifically, we have spent a lot of time figuring out ways to essentially analyze data closer to the source so that you get the insights that are needed in an intent-driven way based on the things that you care about, so that you're not essentially storing this data at the edge or having to essentially ship it really far from its source, ultimately incurring a lot of costs and hoarding the data. And so there are a lot of interesting problems here in terms of how to manage this data, how to get insights from this data as close as possible to the source. And maybe one more thing is, of course, this also highlights the importance, again, of software, this having a software first approach here where, if you have distributed data centers, what's really important is the ability to manage them remotely. And I think we can talk about this more as we progress in this session.